welcome everyone. Hello, and my name is David McElnay, and I'm representing the Executive Committee of the Urban Design Panel today in introducing an exciting panel topic, modular construction with Roger Krulak. Um, as you know, and those of you who are new, the Urban Design Panel is sponsored jointly by the American Institute of Architects, the American Planning Association, and the American Society of Landscape Architects, and is composed of professionals from those three organizations with a shared interest in urban design. So we're joined today by Kathy Wendland from the AIA Oregon, who has hosted this event for many years and continues to generously offer this monthly Zoom meeting. Our panel presentations can be found on the AIA Oregon event calendar, as well as their weekly Thursdays at 3 newsletter. I recommend you sign up. So UDP, Urban Design Panel presentations, are held every third Tuesday of the month. If you want to request a registration or suggest a future topic, you can simply send an email to Kathy Wendland at AIA Oregon. She's going to put her email in the chat for us, and take a look at those other resources as well to just click a button and register. So this presentation is going to be maybe a little shorter than some of the ones we've had. Roger is interested in question and answers, and I'm sure we've all got a bunch. So for the Q&A, please put your questions in the and comments in the Zoom chat box. You can certainly raise your hand virtually at the end of the presentation to be called on by questions. So our executive committee member, Fiona Lyon, will be managing that chat Q&A for this meeting, and we'll pose the questions following the presentation to Roger. You can also send follow-up questions directly to today's presenter via an email address, should he choose to drop it in the chat box. And I'm going to leave that up to his discretion. So these presentations are recorded and archived and can be found in the link provided in the chat by Kathy. And as like in last month's session, we had an AICP credit, which functioned perfectly. We're not teed up for any CEUs today, as far as I know. So with that, I'm going to turn the meeting over to our presenter, Roger Krulak, who comes to us as President of FullStack Modular, LLC. Roger's the founder and president of FullStack, and he's here today to share more about innovation and benefits of modular design and construction techniques, hopefully show us a few interesting examples as a leading innovator in design and manufacture and construction, mostly in the mid to high rise sector of modular and in obviously very urban environments. Roger, if you're ready, please take it away.
Thank you, David. I appreciate it.
Sure.
And thank you all for coming today. I'm super interested to have a conversation and tell you a little bit about what FullStack Modular is and the way it defines its own space within the modular space, or that which is called modular. One of the things I like to start with is that modular is a pretty lousy definition of anything, because you could be talking curtain walls, you could be talking panelized construction, you could be talking about light gauge steel solutions, you could be talking about modular furniture, you could be talking about just about anything. So I like to sort of parse out what the world of modular is from my perspective, and then obviously the things that I just talked about are modular components like curtain wall, etc. Then there's sort of a big industry of panelized construction, whether it be wood or steel, or sort of a fully integrated system. And then what FullStack focuses on is volumetric construction, or that the Singaporeans call prefabricated, pre-finished volumetric construction, where we are trying to build as much of the building as possible offsite and have as minimal amount of work as possible happening in the field as we stitch the units together, stack them up like Legos with an erector set, put it together, and it's done. And so that's what we do, and we at FullStack focus on mid to high rise buildings, and we are a all type 1 construction solution. Our system and our process is fully integrated from design through industrialized manufacturing and construction. We, as a system and process, almost always work with local architects to integrate the process of our system into the development process. And frankly, it really only works one way, which is basically design build. I don't know any other way to define it. This is sort of our executive team. Lots of development experience, known each other for a long time, and we understand construction, development, and design pretty well. This is FullStack's core, frankly, modular proposition, which is lower building costs, faster development, safer work conditions, greater time and cost certainty. We'll talk about that a little bit. Very little neighborhood disruption. Our mods are fully finished and they have a facade on when they go to site. So all the work and all the workers happens within the building for the remaining, stitched together work that has to happen. And then the fact that we are in an industrial space allows us to be very effective. And as a result of that, we have significantly less waste than a conventional process. It all also happens under a roof, which I know it never rains in Oregon, but not having to worry about that is a big advantage. I also know that that the neighborhood is very focused on sustainability, so the mods are very tight, the systems are very tight, the operational carbon reduction is all based on things that you pretty much all understand. The thing that's worth noting is that that the system that we use is also very friendly to all of the elements that reduce operational carbon. It's really easy. You have a very tight envelope. Electrification is sort of preferred method where and when possible. And then the mods themselves are incredibly airtight. So integrating sort of ERV or distribution is pretty simple. And communications between systems and BMS, et cetera, is very easy when you're doing modular construction because it's not sort of trade jurisdictionally organized. And so we can do in the factory anything that makes the assembly of the system effective. And then embodied carbon, pretty much the same thing. And I know I'm talking to people in Oregon, but I'm going to tell you that steel is pretty darn sustainable, and it's almost all recycled, although it doesn't have the carbon footprint of wood. It's still very, very reused, and very little heat used to reshape HSS members, which is what we basically almost all of our system is HSS members with light to medium gauge steel infill. And then we interestingly, if you're building in a factory, excuse my cough, for industrialization, you have complete control over what you're using in the building. We buy everything because we're all one system, one trade, et cetera. We can incorporate highly sustainable products within the system without much problem. And this tends to be one of my favorite slides because it does explain what's the difference between what we do and sort of the conventional process with a very little bit of snark, but it's true. Anyway, traditional process, we all know this, you go into design, you bid it to some general contractor, you get preliminary cost estimates. It's all too expensive, value engineer it, revise the bid, et cetera, et cetera, et cetera. Then you build it, and then you figure out what the final cost is at the end. The difference between that and integrating it into a design build, or what we call design manufacture construct, or I like to say run DMC, allows you, because in a factory, all we have is material, labor, and overhead. It is easy to quantify the associated costs and the remaining work with what we do. And as a result of it, you can get preliminary costs very, very quickly, and you can literally get final costs established, including the on-site work, before you start manufacturing. So your commitment for actual costs ends up happening much more rapidly, as long as you can put your pencils down and pay attention to the fact that everything's going to be built immediately and you can't choose your tile or paint colors later. It will go much more quickly and be cost affected very quickly. And as a result of that, between the on-site work and the manufacturing in the factory, you get some time savings out of box, and then the more you repeat the process, the DMC process, for a building type or a product type, which doesn't have to be identical looking buildings, but similar product, you can decrease the design costs time over time. And right now, we're working on a project in California for San Luis Obispo, Cal Poly San Luis Obispo, and we are already seeing it's 8 buildings, and we are on the 2nd building, and we're already seeing significant design cost savings, and also sort of unit cost savings as a result of the repetition of the process. This is our production. So as I was describing, our system isn't productized to the level that you choose from a catalog of what kind of mods you want. Although if you want to do that, we're happy to make it happen. But what we do is we figure out a way to create flexible components that elements can be repeated as much as possible. So, for example, we come up with the maximum amount of bathroom designs that we need in order to meet the market, and then we're going to try to shrink those to as few as possible. The same thing with kitchen layouts, as few as possible. Doesn't mean you can't have variety, but you want as little variety as you can live with to meet the market need. So, yeah, happy to answer those questions in a little bit. All right, so the idea is, as you can see, we've taken the elements that we showed in the previous thing, and we've organized them into 1, 2, and 3 bedroom units, but they're still using the same elements, the same chassis, et cetera, so on and so forth. And that is what increases speed, and as a result, decreases price. So we're actually working on redoing this, but we actually have go onto our website, FullStackModular.com, and go into try the design, and then you can mass out a few buildings yourself, and it gives you unit options for the massing and lets you put a couple of facades on it, just to think about the way we think about parametric design process. And I think more importantly, for sort of developers and architects and engineers, the one thing that we do is something that's very similar to what in the UK they call quantity surveying, but we really build the building from an estimating perspective. We build the building from the inside out. And what that means is that we're taking all of the elements that go into the building, and we create what we call subassemblies, which are subcomponents of the building system that creates the building. And then those subassemblies go into the units, and those units go into the ability to sort of rapidly prototype different size buildings using the same components, using the same elements, et cetera. It gets rapidly requantified, and then what it provides and puts out is a cost stack, and the cost stack tells you where you're spending your money. And that way, when you get your final cost, you can actually see what is driving the cost and what the opportunities are associated with. So I said the word subassemblies, so now I'm going to explain it. So in industrialization, certainly for the built environment, and for almost all other industrialized construction, we organize our construction by assemblies and subassemblies. So the assemblies are putting everything together, and the subassemblies are things like facade, bathrooms, kitchens, flooring subassemblies, mechanical subassemblies, et cetera. And what we try to do in the factory is we organize the assembly of all of those subassemblies and components in the most efficient way possible. So at FullStack, all of the workers, although we are signatory with the building trades, the workers in the factory have no jurisdictional separation, so they can do anything they can do well, wherever and whenever the labor is needed. And that makes the ability to take advantage of the process efficiency of building. And then once you have those sort of optimized units for the market that you're talking about and the need that you're talking about, you can put it into a small building or a large building or a different shaped building. It doesn't really matter. It's really building blocks, literally building blocks for the system and the process. The other thing worth noting is that it is a fully integrated system. It's SMEP plus facades, so structural, mechanical, electrical, plumbing, and facades. It's all one thing. It all goes together. It all has the same tolerances. It all has the same system. It's built absolutely to theoretical, which means that what's on the drawing actually gets manifested in the building, because in a factory, you're not on site. You can only build to theoretical. And so it has to match when you get it on site. Some of the advantages that we have here is that we have this structural system, which can go up to 45 stories in a non-high seismic area, and up to 28 or more in a high seismic area like California or certain parts of Oregon. We have a self-sealing facade system, which we use for many of our buildings, but not all of them. And then it's a fully integrated solution. We can work with a general contractor, or we could provide a turnkey solution. It doesn't matter that much to us. It is, as they described, built-in sustainable. It's not an effort to say, let's add sustainability. It is by itself sustainable. And then the other thing that's different about what we do is we do full interior fit out. Everything's completely finished. All of the kits to connect it are provided and shipped in the mods. And in addition to that, it's made right here in the United States, and everything is shipped from the factory to the field, ready to be installed. The other thing worth noting is that FullStack Modular's system, you give us as a company something to sit on, whether that be a platform or a foundation or on top of an existing building that has additional FAR. It doesn't matter that much to us. And then from that point all the way through the parapet, it's all mods. So elevator shafts, stairwells, stairs installed, all of the distribution, if any, outside of the units gets done as stacking the mods and the associated shafts. All of the systems are either using UL assemblies or systems that we test ourselves. It's also modular buildings are incredibly quiet, which is worth noting. And this, of course, is the tallest modular building in North America, not in the world anymore, although at one time it was. This is a project that we're working on in California. This is a project that is permitted in LA and hopefully for homeless housing actually, and hopefully it will get built pretty soon, although it's permitted. And now, as I said, we're working on a project for Cal Poly, which is about 6 years of work and 8 buildings. And I know you had a bunch of questions.
Thank you, Roger. Yeah, I can have it. I'll try to kind of relay. There's a bunch of questions that have come in. I think I'll just start feeding them to you. David asked, what are the design constraints of the DMC process in terms of materials, articulation, facade choices?
Boy, I'll bet that's an architect. Anyway, so there's lots of flexibility. The parameters are basically based on transportation, sort of high costs, and sort of a desire to minimize the variation to the extent possible. And beyond that, there's a lot of flexibility. So you can change the ceiling heights, you can change the mod widths, you can change the mod lengths based on sort of standard code, et cetera. And facades are basically somewhere between a rain screen and a curtain wall. So it's attached, so you can pretty much attach anything you want to it. Windows, fit any kind of finishes you really want, and then obviously you can articulate that. Let me see if I can pull up something here. This is the project we're working on right now. If I can pull it up. Let's see if it'll come up. Let me see if I'm sharing still, right? Am I sharing? Yeah.
We see your kind of black screen with the contact. Yep.
Yep. Okay. So just very quickly, this is a design from Steinberg Hart.
Oh,
sorry,
Roger.
We're seeing the last slide.
All right. So let me try one more time. Share. No. Let's see if it'll work. Okay, let me try one more time. And let's see if this works. Share. Okay.
Oh yeah. Okay, we see that. Yep.
All right, great. So I just gonna show just because I could quickly get to it. So this is designed by Steinberg Hart. This is the Cal Poly project we're working on right now. These are modular buildings that using our system as an example.
Wow.
That blends well into the next question, which is just, what's your typical project type, dorm, market rate, residential? If you could kind of characterize who you're working for, what you're usually building.
Yeah. Great question. So we are, it's all type 1. We use no concrete. It's all steel, cementitious board. So we really tend to excel above anything that can't be built out of traditional wood, sort of 7 floors and up. Although there are exceptions to that. If you don't want it to burn, it's pretty good. And it's obviously it's got some value. And then the markets that we work in, I mean, hospitality, student housing, some mixed affordable housing, market rate. It's generally just in that sort of in the elements that create sort of unitary things that are generally not wider than 14 feet as in the majority. Doesn't mean you can't have units that are, but that is one of the drivers. But that, it's a tool that we ask you to sort of just share agency with our parameters, and then you have lots of flexibility.
Awesome. All right, we got a bunch more. Jamie's curious, how do your timelines account for the permitting process and just local design guidelines and all that? You're obviously spanning a lot of different jurisdictions and and counties and states.
It's so good. A super good question. It's actually pretty easy. So the interesting thing is that modular, although I hate to admit it, sort of really comes out of the HUD manufactured housing world from a permitting and jurisdictional process. So usually, in almost all states in the United States, with the exception of a few cities, the approval for the modular portion that was building in the factory comes from the state, and the state has an organization that is usually it's not even monitored by the state, but it's monitored by a third party, and the third party is a third party we work with all the time, and they have other third parties, but I'm just saying that we work with all the time. So the interesting thing, hi Guy, the other thing that's interesting about it is that eliminates the on-site inspections for all the things that are happening in the factory, and then you're basically left with special inspections and those things which are finalized systems, etc.
Okay, I'm going to kind of pair together a couple questions. Stacy and Justin are hoping you could talk a little bit more about kind of industry obstacles that you've faced for modular. I think Stacy commented back in 2022, Oregon was not supporting modular construction that occurs outside Oregon, Washington, Idaho. Has this changed? Could you give us what is the current landscape?
Yeah, I mean, look, it's interesting. We're at an interesting time because there's a lot of acceptance of modular construction because people need housing, and then there's also the obvious resistance that you would expect from people who think that they're going to lose opportunity as a result of it. So you have legislation making its way through the process. So there's countervailing things. I was just talking before we started today that Oregon just passed a law that says that things that are built using public money have to be prevailing wage, even if they're off-site, which is we don't have enough time to talk about it, but it's sort of absurd because what prevailing wage is it? Is it made in Idaho prevailing wage or Iowa prevailing wage, or what are you talking about? Because it could be made anywhere. So that's happening. But we are very trade aligned, so we have a really good relationship, and we think there's a way through it. But so we're seeing adoption and acceptance, and also resistance, and that's sort of the stage at which the industry is at.
Great. Maybe
welcome to what tries to act as democracy. So.
I think I was just going to throw in if you could maybe give a handle on kind of the shifting landscape of tariffs and material costs, and it feels like there's a lot of factors or variables that are right now. I'm sure
there are. Yeah.
So if I think one of your earlier slides talked about your higher cost certainty, and how do you feel any bit of confidence right now?
Well, I mean, look, so I guess the question you're asking is are tariffs going to affect us? And of course they are. I mean, we don't use a lot of, we don't use foreign steel, we don't use a lot of pipe, et cetera, but there are definitely concerns about, sort of rising costs of things. The thing that I can tell you is that the opportunity for cost savings is generally not material. So if you're thinking about us in comparison to conventional construction, the opportunity is a labor vig, right? You can build much more efficiently in the factory than you can in the field. And even IBEW said a couple of weeks ago that it was, 66% more efficient to build in a factory. And that's the electrical union. So if you think that's the vig, you got to figure out what they're getting paid. But then the countervailing costs associated with that is that you have much more design for manufacturing costs. You have higher design costs because you need to give specific instructions for the workers in the factory who are generally lower skilled. That's one countervailing cost. And then the other countervailing cost is transportation. And transportation for wide loads is more expensive than transportation for trucks. Advantages to that are, once the foundation is, you have 70% less traffic. You have basically no deliveries once the mods start to get delivered, but you do have the cost of wide loads and street closures or the associated department transportation permits, et cetera. But pluses and minuses can still sort of equate to, 10 to 20% cost savings. So.
Great. Yeah, Lucas had kind of a similar question stemming from this. Just, what does the site construction footprint look like? Are there challenges with right-of-way closures to accommodate the craning? And, I think a lot of the transport logistics, like how do you kind of queue up a project to put the pieces into place?
I can tell you that's not the thing to worry about, honestly. I mean, it's something to talk about, but it's not the thing to worry about. It's like, and frankly, Portland for sure understands logistics. I mean, it's a logistics hub, right? So it's either boat, train, or truck. And you have to figure out what the best opportunity is from a logistics perspective for that purpose. But I've seen very few places where I can't get this mod into this location so that I could build the building. It certainly doesn't generally get that far, but I'd say it's rare that you have that kind of, it's not, even though it's different, it's not something to really worry about it.
Roger, is it fair to say that most of it can be picked? These can be picked by a tower crane. So
it's super interesting. Yeah, it's a great question. So I didn't show that detail, but our mods have lifting lugs in them, and you can actually see the lifting lugs if you look behind me.
Yeah.
So the lifting lugs stay in place. So you just pick up them up with an S hook with a crane. And yes, it's interesting because in New York, there's this ridiculous insurance requirement if you use a tower crane, but not the same insurance requirement if you use a crawler crane. And we all know that tower cranes are much safer and easier. And our system as a whole, the structural system, has a built-in ability to tie back tower cranes to our building. So we could, it's part of our system. So what we try to do is make this really an erector set. So tie back, simple lifting lugs there, really easy to assemble. And yes, if it's a tough, as I know, every time you drive through Portland, there's tower cranes everywhere, even if they're like a 6-story building. So yeah, that's how you would do it. Our mods are roughly, they're heavy. Our mods are roughly 90 pounds a foot, fully finished. So, you figure somewhere around 35 tons, 35 kips, whatever you want to call it, because it's the same thing. So.
Cool. Related to insurance, different type of insurance, property insurance, Omar asks, are there challenges for modular? Are property insurance challenges for modular less of a challenge outside of California? Sounds like in California.
I mean, property insurance, well, let me put it this way. The insurance companies, if they are, from a builder's risk perspective, there's far less risk and they should be giving you a huge discount. There's certainly less workers' comp because there's not that many workers on site. From a building operations perspective, it's built to the same code. So it's the same product. And early on, we had a lot of conversations about this. So it's a building. Once it's finished, it's just a building. I mean, I had a bunch of appraisers early on say, like, is it worth less because it's built modularly? I'm like, is it worth less because it's poured concrete versus steel or CLT? I'm like, I don't know what it matters what the method is. It's still a building, right? If it's a building. So.
Let's see. Guy wants to know. At one point, FullStack was manufacturing modules up at Sloan Island. Does that still happen?
We are not there right now. We are not there right now. We got this very 8-year project, so we moved down to California for now. But we are super happy to come back I mean, as soon as we left, our airport got finished, and it's so much fun to go to. So I'd be more than. But we are talking to many people in Oregon, and I'm super excited about the idea of opening up there. We are looking at factories in a number of places in the country for all the reasons we talked about. So happy to come back. I miss the food, not the weather, but I miss the food.
I was hoping you could talk a little bit more about just the workflow of these facilities. I mean, if you had, I don't know, I'm just throwing out a ballpark, 40 employees, are you saying that all those 40 employees have like all the trades built into their skills and can kind of tackle anything at any time? Or is it like there's...
Yeah, it's not exactly.
Of...
So how do I explain this? So basically, the idea is that the idea of industrialization is that you have an efficient process by which you're assembling all of these things. And so therefore, you need people that have the skills in order to do that. And we spent a lot of time creating design for manufacturing drawings so that the work is understandable and achievable. You still have to have some skills in order to do it. So what we do is we have, with the building trades, we have experts in sort of the major skills that you're talking about: drywall, painting and taping, plumbing, electrical, etc. And then you have a whole crew of workers who get trained in those skills by the experts who are actually building trade, regular union rate, a lead foreman. And then that is where the skill sets come from. And then you have your production, for lack of a better term, lines, because I don't want to get into this. So and those production lines are run by a production manager trying to move the industrial construction and assembly as fast as possible. So you have skills going into the process and production managers pushing the process. And then you have quality assurance coming in and checking to make sure that it's right. That's industrial 101. And so that's how we bring this. Hopefully that
thank you.
Gave you a good answer.
Yeah, that's helpful. Yeah, I think Nathan has a great question related to this. Just, I think you, having met you, I know you have a lot of energy. Most people don't just set up a facility overnight and then move shop to California. And,
we have tons of energy. Look, at the end of the year, I mean, to be fair, you need about 10 years worth of work to completely amortize a factory in its full. Okay. And I'm talking to endless amounts of cities right now. I mean, you name it: San Francisco, Chicago, and basically my Maynard, Texas, et cetera. And I'm like, I need a 10-year commitment, because then I can really provide value. And so that's a general answer.
Mm-hmm. Great. Okay, that's helpful. Let's see. Heidi wants to know, what are the biggest misconceptions or points of misinformation that you see, particularly from the public and local officials?
I have to say, the only thing I can say sort of about local officials is it's not too much, but the one thing I can tell you is that people don't really like their jurisdiction stepped on, and so the modular units are, as I said, they're approved by the state and that system. And I have had many local authorities having jurisdiction fight the state, saying, "Oh no, we want to leave this open so we can inspect this," or blah 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 blah. And thank goodness, so far the states have been like, "Doesn't work that way. Here's what you're going to get, and here's how it works." But it does sometimes create a little bit of back and forth. And then the other thing I can say is, certainly in California, the understanding of fire protection and the way that it works is confusing even for people that are in those positions sometimes. And that the fact that it's 3-dimensional mod, and that some of the fire safing is related to the mods as opposed to sort of a sub-assembly, that's a 2-dimensional item that you can pull out of a UL assembly, also takes a little bit of collaboration and intention to overcome. But code-wise, it's the same code, so it doesn't, it has to apply exactly the same code. It has to perform exactly as code requires it to.
very helpful. Let's see, there's a question about just talking a little bit more about like dimensions of units and kind of scale. And I guess kind of related to that, I would add, is there any benefit, like would this technology ever be used for like an event space or a large indoor, or is it more of these kind of pods
We are
applicable?
we are really, I mean, our system and our space. So look, I mean, we're one small component of what the modular world is, but our system is specifically valuable to things that can be unitized in something that can be shipped on a truck or a boat, et cetera, which is sort of 16 feet or less, 58 feet or less. And our normal modularity is generally somewhere between 10 and 14 feet wide and somewhere between 25 and 37 feet deep. And those are what the majority of our system uses. And yes, you can combine multiple mods, as I showed, to make units, et cetera. So that's not a problem. It just needs to be organized in a way that's trying to optimize for off-site work and minimize for on-site work, but it still allows you lots of flexibility in how you organize the units amongst each other and with each other.
Right. Let's see, Guy has another question. Is the modular building lighter than an equivalent mid-high-rise type 1 reinforced concrete structure? And is there scope to save money on below grade construction as well, foundations and whatnot?
Totally.
Especially suboptimal geotech.
Yeah, good question, Guy. But the answer is that our units are about 25% lighter than sort of conventional mid to high rise buildings. Our system is very efficient in the way that even though you have, sort of repetitive, floor to ceiling sandwich, et cetera, it's still significantly about 25% lighter. So that in the right conditions and the ground save a lot of money. So.
Fiona, I saw it. It's David again. I saw a question earlier about, I thought I liked that, which was, how can architects be of value in this process? Maybe you can speak a little to that, Roger.
Of course. So we aren't architects, we have a system and a process and a design for manufacturing team that is highly capable. But we are not architects, and we try to our system remain flexible so that architects can put their own sort of imprimatur on a building, even though we ask them to share agency with some parameters that are sort of additional to multifamily, like location of plumbing and et cetera. But beyond that, we have no interest in having our buildings look the same, or we want them to respond to the market. And that includes the way that people experience it, and when they live in it, and the way that people experience it as it exists in the community. And in my opinion, if I had my druthers and I was making the rules, I would say that's what architects spend their time doing, because A, they can do it really well, and B, like, we're pretty good at the parametric process. Like, just give, so that's how our perfect architect interfaces with us. And obviously all of the sort of the other things that they're so good at, code and sort of interface and presentations and all that stuff. But that respectful back and forth relationship drives value for sure. It also, by the way, worth noting is, like, we never need you to make construction drawings. It's not necessary. Once you get permit level drawings ready, you're done, except for obviously, to be design assist for anything that's going forward. But that's going to really be how we create instructions for what's happening in the factory. So we don't need anything past that. So you can spend the time doing the things that I think you do best, which is sort of design and interface and living experience and all those things. And we'll take care of creating drawings so that we can manufacture them and erect.
Very cool.
That's interesting. Let's see, Pamela just threw in a question. Thinking about like educational stuff, have you done K through 12 building classrooms with modular? Do you have a DSA pre-approved design?
Yeah, I mean, I've talked to some people about sort of smaller, sort of unitary classrooms, even sort of locally here. Our system doesn't really lend itself that because we really do try to be sort of unitary. But if you need it, small classrooms, etc., it's pretty easy. Our system works really well for, say, for instance, hospital beds. Like if you have hospital rooms and you build a huge operating center, and then you have sort of administration on the first couple of floors of a hospital, and then you want to put 10 floors of rooms. That's great for us, and that works really well. The classrooms generally larger space. It's hard to say. But if it sort of needs to be wider than 14 by 58, you can do it. But there's some loss in value proposition. I have 15 designs of schools that never happened, if you're interested in looking at them. But it's like, they generally doesn't work. I mean, there are, by the way, modular companies who are incredible at doing schools, and that's all they do, and they're really good at it. But our system isn't necessarily very well suited.
Hi, Roger, it's David again. I'm wondering if you showed the first slide there was the Brooklyn project, I guess, next to the stadium. So what was your role? What was FullStack's role in that, or just was that an interesting?
Yeah, it was like the trying to prove the modular system for mid to high rise buildings, and that's what we did. So it was we did all the manufacturing of that. So
you were in what state when you did that?
Oh, that's in Brooklyn. Yeah, that was in Brooklyn. Our home state, which we're not in right now, was Brooklyn. But we're now in Connecticut. But we really were born in Brooklyn, and which basically made us figure out we had to create density and height and et cetera. So.
Very cool.
All right, I'm gonna throw my own fun question. If you were to pick a unit to live in of all the projects you've built, which one's your favorite? Would you be a family?
So I guess let me answer it in a slightly different way, Fiona. So what is interesting about our system, if you think about it, is that there really are no internal columns that ever get in the way. So our system is integrated into the modularity of the process. So everything is free and clear. Nothing's in the way. And as a result of that, the ability to have significant light in the units, and it feels very open, even as they're smaller. So and the organization, frankly, of keeping the plumbing sort of towards the hallway also leaves open the space that's sort of the most interesting open airy sort of space associated with it. So I like the way our units look when they're finished. There are finishes I like better. There are facades I like better. By the way, the facade that I showed you for what we're doing here in this school is beautiful. It's expensive, but it's absolutely spectacular. So it's just clean and organized. I mean, I love, and so I'm a fan of that. But that's the rest is sort of, they're different. A place in Sunnyvale, California is going to feel different, just like you would expect, than a place in Portland, Oregon, or San Luis Obispo. They all have their own characters, and they are embracing whatever it is that's there, right?
So Fiona, I have a question for Roger. Going a little bit deeper into the details, I had asked it earlier, was do you create unitized facades that work to your module, or do you work with facade unitizers that hang them on your modules?
Yes.
Both
we do either. But our system is a system. And so whether we're making that facade or whether we're buying that facade as a sub-assembly of our process, is the same thing. And it's the same thing with bathrooms. Whether we're buying bathroom pods or we're making bathroom pods, it's all an integrated assembly to our process so that it's fully integrated. So in other words, I'll give you an example. Our curtain walls, when the steel is being manufactured as a chassis, there will be facade clips welded to that chassis to accept the facade that's coming, whether it's coming from us or whether it's coming from another. And that's the way we think about industrialized construction. Everything is organized so that it's integrated in the process, and it doesn't matter who's providing it. It's still the same real source of truth, basically.
Wow. So some of us who go back a few years, that's pretty cool to hear as far as the precision of all of that, and makes so much sense. But I mean, we've all been kind of working towards that kind of thing. It seems like forever.
Yeah.
Quick other detail question was, how do you modularize fire-rated elevator shafts and stair assemblies?
Yeah. So like I said earlier, whatever you can have a UL assembly to do, and you can think about certain things that like fire barriers in a modular condition are quite hard to have because you can't really go floor to floor because you have a ceiling, right? As an example. So we'll test that. And we spend a lot of time at the testing labs and we burn it. And then we take that assembly and then we use it into our systems.
Go down and see our friends at Architectural Testing in York, Pennsylvania, or something like that, right?
Yeah. We've been spending a lot of time in Buffalo lately. It depends on what state you're in, because in California they only have some approved companies, and most of the approved companies in California are like testing agencies that only work for people who are their members, like FMI, for instance. So it's a quandary, but yes, you travel wherever they have a furnace big enough to burn whatever it is you're trying to burn.
Right. Fiona, I think more questions are rolling in there.
David, I
we got a
think
couple minutes.
my screens have frozen. Do you mind? I can't access the comments.
I had the devices myself, by the way.
I apologize.
Stopped, but I went to my phone.
Roger.
I saw it go by too quickly to know what the question was off the top of my head, but whomever asked it, feel free to chime in and ask away.
I was curious what the lead time was for manufacturing units once you have a design approval.
Yeah. So once you have permits, it sort of depends a lot on how the development team feels about sort of early release of things that are low risk. And I'll explain what that means. But for instance, structural engineering, for example. Structural engineering is never but rarely challenged by an AHJ because they don't really want to step on the structural engineer's license. So ordering, say, fully stamped engineered chassis early is not a big risk. On the other hand, like putting in a HVAC system that isn't sort of stamped and approved by the AHJ is often risky because they're going to make comments or give you comments. So and the two biggest long lead items, and I'm sorry this is a complicated answer, but it's as accurate as I can make it. The other thing is facades. And again, facades are a bit the same thing, but they do have some risks. So the sooner you can release those two things, the quicker you can get to manufacture. And so once you've released those things, and they roughly take, say, 3 months to ramp up for a large building. If it's a small building, it'd be less. And then once that happens, we can go into production and we can manufacture in basically a 12-day cycle, roughly 3 mods a day. So figure like 1,500 feet a day, fully finished, ready to go to the site. And so divide that by the square footage of the building, and you have sort of how much time it takes. And then what we can manufacture in, you can set about 12 mods a day. So, 3 days worth of work can be set in a day. So then add that to your calculation, and then the stitching it all together is very short. I mean, there's not that much work to do after that.
Now we got a few more minutes if folks have more questions. Roger, I'm just curious. I think you kind of started to get at this, but just I'm kind of curious, like, is there an intersection of, there's a lot of interest in Oregon for mass timber and modular. Like, do you see those things coming together? It seems like you're kind of focused on 7 stories above. Seems like maybe mass timber is kind of like the sweet spot just below that.
Yeah,
Like,
I mean, I'm not surprised that in Oregon, from an architect, I'm getting a conversation about that. But I mean, I have my own personal views. And by the way, I've spoken to tons of companies who you know about sort of. I am. So the interesting thing about our steel system is that the structural the structural sort of numeric regularity that you can do in steel is way more flexible than it is with generally mass timber. And as a result of that, you often can't lay out the units to have sort of like the free and clear space that I just described. So you end up with columns in places that you don't really want them. So I don't know, but the places where I really think there are super interesting opportunities of a combination or integration are structural plywood. I think structural plywood eventually in certain units and systems has a lot of opportunity. And then the other day I was reading about superwood, which I think is super interesting. And if you haven't read about it, you should look it up. It's super fascinating. Which basically is as strong as titanium and is totally made out of like wood byproduct and looks absolutely beautiful and is strong as steel. So I don't know what happens when that happens, but it's super cool. So my answer is that as it evolves, I'm sure there will be intersection, but I'm not sure what it is yet.
Yeah, and there's a lot of folks in the mass timber space, in the CLT space, that are working towards modularity within the constraints of that material. So yeah, I see your point. I noticed you called basically a module as a Virendeel beam. So, you know, it's pretty easy to understand the value in that. Very, it's almost like lace work basically, but it holds itself up.
Exactly.
Yeah, so makes sense. So we do have a couple minutes. I do a hard stop at 1 o'clock, Roger, just to let you know.
Yeah.
You know, my board, we may circle back to you and to thank you and have any follow up, but you know, it was real pleasure to get you out here today and make you do a speed run through FullStack Modular. I'm having a little trouble understanding sort of your network, but it sounds like you're out of Burlington, but you're in California, and you have a series of factories and a headquarters, or how are you kind of working at this point?
Sure. I am posting my email in the chat. If you want it, you can obviously also look up fullstackmodular.com and you can get access. We right now currently have a factory in Connecticut, in Hamden, Connecticut, which is like the replacement for the New York factory, but sort of hang on with that. And we have one in Carson, California. And I'm talking to, like I said, multiple cities about trying to meet this need with the parameters that I sort of already. It's about 6 months to get a factory the way we do it up and running, assuming you can find a building that is suitable.
Right. Well, cool. Well, that's good
Roger,
to hear.
thank you so much. Yeah, this is really fascinating stuff.
My pleasure. My pleasure. And yes, all questions are always welcome, and ideas as well.
Right on. Well, I'm going to walk down the hall here and talk to my friends in the building department about the pre-stamped state of Oregon approved. That works for trailers and for, you know,
Exactly.
RV. What happens when somebody walks in with a modular building, you know? So
yeah, no, it's interesting to note that like what we do here is like even our sub-assembly providers, they get a label capacity from our third-party inspectors so that literally when it leaves their factory, we don't have to test it. We don't
It
have to.
didn't, yeah, no, that's.
So the more you can do that, the better off you are, right? It's just
Mhm.
everything is completely code compliant, inspected, signed off. When you get it to the site, it's pretty ready to go, other than testing the complete system as it's organized.
Well, obviously, there's no one more expert than you. All I can tell you is that in Oregon, it's kind of a known factor, that process, but not necessarily for a whole building made out of modules. So any way we can help, obviously, we're here. So I'm going to call it for today. Roger, I'm going to thank you so much. Give you a second to say anything you want to say before we jump off here.
No, I mean, like, let's build 10 years of worth of pipeline in Oregon so I can come back and have some good food and spend more time with the people that I like. So
Right on. Well, we have a pent up need for housing. The city's leaning into
I know. I've talked to state level government, local government, so I get it. So
Cool. Well, thanks everybody for attending the Urban Design Panel. For July, we've got more topics logged in for coming up in August and September. We're going to do a collab with the AIA Summer Social coming up here July 24th. Just going to drop in and visit with everyone, tell a little bit about what we've done at the Urban Design Panel and some of the recent thoughts we have from some of our executive committee team here. So put that on your calendar. Again, Roger Krulak, thank you so much. FullStack Modular.
so much. And I will say, like, ping me on LinkedIn. Like I said, I do podcasts probably twice a month. So if you're not sick of my voice now, you could listen to enough podcasts to get that way. So.
Will do. Take care of that cold, and everyone.
Thank you so much.
Care. Thanks for showing up. Thank you, Roger.
Yeah,
Have a
bye-bye.
great one.
Thank you, Roger.
Bye-bye,
Take care.
Fiona.